This is section 8.6, part 2. We're talking about geometric sequences, and on this side of the page we're going to talk really about the general rule or the general formula. As we talk about geometric sequences, we have this formula here. A of n equals little a times r to the n minus 1. Let's talk about what these are. A of n, that's function notation. That means the nth term is what we're going to find. A is always our first number in our pattern, and r is our common ratio, where n is how many terms we want. So if we want the fifth term, we're going to put a little 5 in there. The common ratio is 2, we're going to put a 2 in for r. So as we think about that, we just need to think about what we're talking. If someone says a to the 7th, that means find the 7th term. We're going to plug in 7 for the number 1. So here's our first one. We're asked to find 3 different things for our problem here. First, we're asked to find the first term. Now there's 2 ways to do that. We can plug in the number 1 in for n. So negative 2 times 3 to the n, 1 minus 1. Well, from our rules of exponents, we know that 1 minus 1 is 0. So anything to the 0 power is 1, and so our answer is negative 2. So the first term is negative 2. Now, hopefully you might have seen that there was a shortcut in doing this. By recognizing the formula a times r to the n minus 1, and you might have realized that a is the first term, and so the negative 2 is very quickly the first term. So that's just a little shortcut that we might be able to use. Let's look at the fourth term. So we're going to put in the number 4 for the value n. So negative 2 times 3 to the 4 minus 1. Well, let's think in our minds, what is 4 minus 1? That's 3. So we have negative 2 times 3 cubed. Yesterday we talked about what 3 cubed was. Do you know what 3 cubed is in your head? Think about it. It's 27. So we have negative 2 times 27. What is that? That's negative 54. So the fourth term is negative 54. We're going to skip down here to the bottom, and we're going to take a look at our fifth term since we've run out of space. Our fifth term, we're going to put in negative 2 times 3 to the 5 minus 1. So that's negative 2 times 3 to the 4th. Teach you a little trick for taking things to the power of 4. You can square a square. So 3 squared is 9, and 9 squared is 81. So we have negative 2 times 81, since 81 is 3 to the 4th. Well, very simply, you can multiply that on your calculators if you need to, and 81 times 2 is negative 162. So our fifth term is negative 162. Let's look up at example B on this. Now, on this one, let's take our shortcut. What's the first term? We'll examine our formula at the top. Our first term, obviously, is 4.3. No work is need to be done if we recognize it from our formula. Our fourth term is just about as easy. Let's put in the number 4 for 4.3 times negative 3 raised to the 4 minus 1. Now let's do this all on our calculator. So to do this, we're going to put in 4.3 times, open parentheses, negative 3 raised to the power of 4 minus 1. We have to put that in all together. We can either put it in parentheses, 4 minus 1, or we can just put in a 3. So that's how our calculator is going to look when we put this in, if you have a graphing calculator or a calculator that has a true math type formula. The calculator is going to take negative 3 and cube it. That's negative 27. Multiply by 4.3 and give us one answer all at one time. So negative 116.1. Our fifth term, we're going to use that and say 4.3 negative 3 to the 5 minus 1. Well, as I plug that in, 4.3 times, parentheses, negative 3 to the 4th power this time. Well, that's positive 372.6. So here's a case of a calculator is really going to come in handy for a lot of these calculations and multiplications. Just as easily I could have asked you for the 50th term or the 100th term, and you would put in 50 or 100 in for n, subtract 1, and work it out on your calculator. Now let's look down here at example 5. Rule 5, we're asked to write a rule and then find a given term for the following geometric sequence. Well, the first term is -4. That means a equals -4. The common ratio, or you might remember that's the common multiplier, is 2. So our formula is going to be copied from the top. Our general formula is a times r to the n minus 1. Well, let's put in the values we know. A is -4, r is 2, and there's our general formula. When you have a general formula, it's really easy to identify the first term and the multiplier. Well, we're supposed to find the 12th term, so put in a 12. -4 times 2 to the 12 minus 1. By now I'm sure you've picked up the pattern that 12 minus 1 is the first thing you're going to think about. So -4 times 2 raised to the 11th power. Well, that's a large number, -8,192. So the 12th term is that large number. As we're looking at these problems, it's going to be important to make sure you keep your formulas straight and understand what we're talking about in terms of what term or how to go about finding these numbers.